Okay, let's do a waveshaper. We have a simple synth here with some scopes and analyzers. And the synth is creating a sine wave tone. Nothing fancy. And the most basic waveshaper we can think of is to put a custom function in between the oscillator and the output. And this immediately changes the waveform, but we can make it completely transparent by using -1 for the minimum value both on the x and the y-axis, and we did nothing here. But as soon as we draw a curve here or do stuff, we have a pretty asymmetric waveshaper, which is something that you can desire or something that you might want to have. But in this case, I will want to create something that's symmetric, but this works as well, so have fun with it. This is the most basic waveshaper you can build, and it works nicely, especially when you are not using high frequencies, because that's the territory for aliasing, as you can see here. Or better to see on a linear scale, maybe. Yeah, there's lots of aliasing here, but doesn't matter. Use it for base. Anyways, the y minimum and the x minimum should be 0, and we will make this a symmetric waveshaper now. So how do we do that? It's pretty simple. First, we take the absolute value of these waves, so everything is on one side of the function. And then we want to know the sign. If this original waveform is above 0, then we want to have 1. And if it's below 0, then we want to have -1. And simply multiply the output by 1 if this was higher, and by -1 if this was lower. So this is the idea. And let's create a node for pre. Also to, yeah, pre. Like preprocess, that's enough. So let's create an input, not a designer, just an input. Get the absolute value, output it, create a sine function here, get the input. If it's below something like 0, then output -1. If it's above 0, then output 1. And this is the sine output. And this is the preparation part. So this way we have this absolute part, and we have -1 where this should be negative. So I create a post node, which will need an input, a multiplication, and the sign. Like this, and the output is going to be our signal. And this way, anything we apply here is going to be symmetric. So this works fine. This is what we wanted. We have a symmetric waveshaper now, which works pretty nicely. So what do we want to do with it? Like this is something like a 10H function or close to it. And what we might want to do is to drive it. So I create a designer called drive, and it will need an input, a multiplication, and an output. So we are going to change the volume inside here, and for this I will create an input called that will use a parameter, and I'm going to convert it from decibels to linear, like this. And this really is what the drive is going to do. input, output, create a knob, let's say from 0 decibels to 24. And yeah, let's take a look at it. Wow, it works. So now we can drive this function. That's nice. So let's draw something crazy here. And if we use a saw wave, then we can see that this waveform corresponds to what happens in the positive part, and the negative part is its opposite. And we can drive it, and then it gets mad. We can also warp it. And I'm going to call this WarpX, and you will understand why. And I'm going to call this process. Or just PRC-like process. So this will use an input. Yeah, let me show this first. If I put a power function here, and with an exponent of 1, and let's say 2, then we can squeeze this function. So actually, squeezing the input is close to something like this. We are squeezing the function, but we are really not doing anything with the function. We just squeeze the input, but this can be done in real time, while transforming this function cannot work in real time. But this is something that's nice. And this is like multiplying the signal 4 times with itself. But we can also take the square root. Let's say if we write here 0.5, that's something like taking the square root, and that's moving into the other direction. And what we want to reach is this value. So a pretty big warping. And I want to control this like to go from -1 to 1 in this fashion. And I'm going to call this WarpX. And inside this node, I really just want to have a power function and an input for the warp and the output. And I want to insert a custom function in between these two nodes, because that's easier than doing the math. So I know that my x minus is going to be -1, and I know that my y max is going to be 4, and this should be enough. I need some bars for the y-axis, and I know that I want 16. And here in the center, where the x is 0, there I want to have a y of 1, like this. And where the x is -1, I want to have a y of 0.25. And where the x is 1, there I want to have a y of 4. So this is pretty much okay. And let's plug this in. Let's plug this there. And we have our warp function, which is pretty much resembling something that a wavetable oscillator can do. But there you are. What you do in a wavetable oscillator in these cases, it's really not a nice thing. But this way it's maybe a bit better. But aliasing is still an issue, but we don't care about it for now. And we can also create a warp y or warp y, and it really is just going to be the same thing, but after the function. And this will drag the values closer to 0 or pull it apart, which is funny to see. And can create pretty interesting sounds right out from basic sine wave, because we are now at a sine wave. So, and basically this is our waveshaper. You can drive it, warp it, and warp it again. And actually, as I told, these can introduce aliasing, especially on high notes, but on low notes this is pretty much okay, as you can see. So there's no noise, basically, that's audible, and people are using this kind of voices mostly for bass sounds. So I think this is a good option. And it's instant dubstep, basically. So I hope you had fun watching this, and this is it for today. Bye bye.